In this lesson, we are going to learn how to find the limits of functions. Okay, so I've already made some videos on this and we are still solving more examples. So let's look at the first example I have here. So let's find the limit as x approaches 5 for the function 2x squared minus 3x plus 4. So let's find the limit of this function here. The first thing we can do is to try direct substitution, okay, where we substitute 5 in place of x. So this is going to give us 2 into bracket 5 squared minus 3 into bracket 5 plus 4. Right, so let's simplify this. So we are going to have 2 multiplying 5 squared, okay, then 5 squared is 25. So minus 3 times 5, which is 15, plus 4. So I'm going to have 50 minus 11. So 50 minus 11. So when I simplify this, that's going to give me 39. So that will be the limit for this function. So let's take one more example. So let's find the limit as x approaches minus 2 for this function. X squared plus 2x squared 2x squared minus 1, okay, divided by 5 minus 3x. So what I did, I'll try direct substitution again and see if it will work. If it doesn't work, then we'll have to find a way to evaluate the limit. So we're going to have minus 2 squared plus 2 into bracket minus 2 squared minus 1 divided by 5 minus 3 into bracket minus 2. So let's simplify this. So we have minus 2 squared to give us 4. Okay, so that'll be 4. Then plus 2 multiply minus 2 squared. Right, so that gives us 8 plus 8 minus 1. Okay, divided by 5 plus 6. Okay, so let's simplify this here. We're going to have 4 plus 8 minus 1. Okay, so this is going to give us 11. And then divided by 11, right? That's going to give us 1. So that'll be the limit of this function here. So you see that after using the direct substitution method, we're able to find the limit of this function. Okay, so now let's take a little more complicated question. So let's take this, the limit as x approaches 1. Okay, where you have the function x squared minus 1 divided by x minus 1. So let's try and use direct substitution for this method also. So we're going to have 1 squared minus 1 divided by 1 minus 1. Okay, so this will be 1 minus 1 divided by 1 minus 1, and that will be 0 divided by 0, which I don't know what value that is. So you will have to find a way to compute the limit. So we can do this by using the difference of squares. Okay, so let's look at the numerator. We have x squared minus 1, right? I can write this as x squared minus 1 squared, right? And then you see that we have difference of squares there. Let me write this again. X squared minus 1 squared. So I can write this as x minus 1 x plus 1. Okay, that's difference of squares. Okay, so now let's go and substitute that into the function. So you have limit as x approaches 1 for the function x minus 1 x plus 1. Okay, divided by x minus 1. So at this point, we can cancel out the common term. Okay, so x minus 1 will take out x minus 1. And we're going to have the limit as x approaches 1 for the function x plus 1. So we can now try the direct substitution. So we're going to have 1 plus 1 here, which will give us 2. So that will be the limit of the function. For you to understand this difference of two squared method that I used here, assuming you have this expression a squared minus b squared, okay, you can write this as a minus b and then a plus b. Okay, so it's the same method that I applied over here. Okay, so let's take another example. Okay, so let's find the limit as x approaches minus 4 for the function 1 over 4 plus 1 over x, okay, divided by 4 plus x. So now let's try direct substitution here also. So I'm going to have 1 over 4 plus 1 over minus 4, okay, divided by 4 minus 4. When I simplify this, I'll have 0 over 0, which is indeterminate. So we'll have to find a way to compute the limit. Okay, so to do this, let's focus on the numerator, okay, which is 1 over 4 plus 1 over x. Okay, so let's find the least common denominator here, which will be 4 times x. So I'm going to have 4x here. Okay, so now let's simplify this. I already have 4 here, so this will cancel out this 4 here. So I'm going to have 1 multiplying x, so that's going to give us x. Then over here too, the x will cancel out, and I'm going to have plus 4 times 1, which will give us 4. So you have x plus 4 divided by 4x. So let's write the function. I'm going to have the limit as x approaches minus 4, okay, of the function x plus 4 divided by 4x, all this divided by 4 plus x, okay. So you have to reciprocate what you have here, right? So I'm going to have the limit as x approaches minus 4, and then I'm going to have x plus 4 divided by 4x, okay, times the reciprocal of 4 plus x, that will give us 1 over 4 plus x. So at this point, you can cancel out this, you can cancel out this. So you're going to have the limit as x approaches minus 4 for the function 1 over 4x. So at this point, you can try the direct substitution. So you're going to have 1 over 4 bracket minus 4. And then this is going to give us 1 over minus 16. So now this will be the limit of the function. Okay, so let's look at another situation. Okay, so you have the limit as x approaches 0 for the function x squared plus 9 minus 3 divided by x squared. Okay, so when you have this situation here, okay, you can try the direct substitution here, but I know you are going to get 0 because the denominator is just x squared. Okay, so I substitute 0 here, I'm going to have 0 squared, so you will have indeterminate form. Okay, let's try this and see. So I'm going to have square root of 0 squared plus 9, okay, minus 3 divided by 0 squared, which is 0, right? So you see that we already have 0 as the denominator, so I'm going to have indeterminate form. So you have to find a way to compute the limit. So in this case, what you are going to do is that you are going to multiply by the conjugate of the numerator, okay, because of this square root function that you have here, or the square root thing. So let's take note of this. If I have, let's say, square root of a plus b, okay, and you have to find the conjugate, all you have to do is to change the plus sign to negative. So I'm going to have square root of a minus b. Okay, similarly, if I have a minus b, then the conjugate will be square root of a plus b. So that's what you're going to do here. So the conjugate of the numerator is going to be x squared plus 9 plus 3. So I change the sign to plus, divided by the square root of x squared plus 9 plus 3. Okay, so now let's simplify this. I'm going to have the limit as x approaches 0. So now the easiest way to do this is to just multiply these terms. Okay, so I'm going to multiply this bracket here by this, and then multiply this also here by this. But the easiest way to compute the numerator here is to square the terms. Okay, so I'm going to have something like this: square root of Okay, let me write this with white. Okay, so I'm going to have the square root of x squared plus 9 minus 3. Okay, then we square this and then we square this. Okay, divided by x squared multiplying square root of x squared plus 9 plus 3. Let me put this in bracket. Okay, so now for us to complete the multiplication of the top terms, all you have to do is to square the terms. So I'm going to have the limit as x approaches 0 for x squared plus 9. Okay, because this square root here will cancel out. So this square here will cancel out the square root. So we're going to have x plus 9 and then minus 3 squared will give us 9. So all this divided by x squared multiplying the square root of x squared plus 9 plus 3. So you see you have plus 9 and minus 9, so we're going to cancel out. So I'm going to have the limit as x approaches 0 for x squared divided by x squared. You can multiply the square root of x squared plus 9 plus 3. Right. So this will cancel out this. We are going to have the limit as x approaches 0 for 1 over the square root of x squared plus 9 plus 3. Right. So now let's try the direct substitution. Let's continue from here. So I'm going to have 1 over the square root of 0 squared plus 9 then plus 3. Right. So we're going to have 1 over the square root of 9 plus 3. And the square root of 9 is 3. So we're going to have 1 over 3 plus 3. And then that'll give us 1 over 6. So that'll be the limit of that function. That's all for this video. Thank you very much for watching. Please make sure you like and subscribe.